Hello viewers, I'm Kausalya. Today we are going to solve problem number 4, 5 and 6 under the topic pure resistive, pure capacitive and pure inductive circuits. Right. So the problem is in a circuit the source voltage is V is equal to 200 sine 314t plus pi by 6 and current I is equal to 20 sine 314t minus pi by 3. So find the following. Here they had given lot of parameters to be calculated. So here the first one is frequency, maximum value of voltage and current, RMS values, average values, and voltage and current in polar form, and phasor diagram, and here circuit element and its value. Right. So there are many things to be calculated. We will go step by step. So the first step is just write down the expressions for voltage and current. Right. So first we need to calculate the frequency, right? So you see here from these expressions you see sine of omega t, right? In the place of omega here we are having 314. So just substitute the values omega equal to 314. So what is the value of omega? It is nothing but 2 pi f. So from this expression just calculate the value of f, which is equal to 50 hertz, right? And the next step is we are asked to find maximum values of voltage and current. So we know the basic expression, right? V is equal to Vm into sine of this and I is equal to Im into sine of this. So here Vm and Im denotes the maximum value. So the Vm is 200 volt and Im is 20 amps, right? Now the second part of the problem is over. Third one is RMS value of voltage and current. So here we should know the formula of relationship between the VRMS and VM, right? So here it is given as VRMS is equal to VM by root 2. Right, 1 by root 2 is nothing but 0.707 into VM value is 200. So just substitute it and find the value. And the next one is IRMS. It is given by Im by root 2 and here Im is 20 amps. So just in the place of Im substitute 20 and the value is calculated as 14.14 amps. Right. Now the fourth question is average value of both voltage and current. So here also by using a simple formula we can calculate. So V average is given by 0.637 times of V max, right? So 0.637 into the value of V max is 200, right? And just calculate the value. Similarly, I average is given by 0.637 times of I max. So 0.637 into 20. So that gives the answer of 12.74 amps. So now we have to represent voltage and current in polar form. So a polar form will always consist of an angle, okay, that is magnitude along with an angle here. So here the value of voltage is, we should always write the VRMS value, right? So here the value of voltage is 141.4 and similarly IRMS is 14.14, right? Next we need to write the angles. So from the problem we can write the angles, right? You see voltage with an angle of plus pi by 6 and current with an angle of minus pi by 3. So here simply we are writing the angles pi by 6 and pi by 3. So pi by 6 is nothing but 30 degrees and pi by 3 is 60 degrees. Just substitute the value of pi as 180 here. That's it. Right. Now the next thing is to draw the phasor diagram. So here how to draw the phasor diagram? We should always have a reference to draw something. Right. So we are keeping a line as reference. And you see here the voltage value is 141.4, right? That too with an angle of here it is plus 30 degrees. So it is drawn above the reference line, right? And the next thing is here you see here we will be having minus sign, right? It is given in the problem. So it is minus 60 degrees. So it is drawn below this reference line and you see the value of current is 14.14 amps, right? Now the next thing is we have to calculate the value of L, that is how we know that this circuit has inductance in it. You see, from the phasor diagram, you see the current. What happens to the current? The current lags the voltage by how many degrees? By 90 degrees, right? So whenever current lags the voltage, what is the circuit element there? The circuit element is an inductor, or in other words, this circuit has only inductance in it, right? So the circuit element is a pure inductance. So regarding inductance, what is the formula? XL is given by Vm by Im, right? This is a basic formula. So Vm we know, Im we know, just substitute the values and calculate it and find it as it is 10 ohms here, right? Now the next thing is the other formula for XL, it is nothing but L omega. So here L omega is equal to 10. What is the circuit element here? The circuit element is nothing but inductance, L. So we need to calculate L here. So L is given by 10 by omega, and the value of omega is 314. Okay, we are taking this from the problem. So once you calculate here, we are getting the answer as 0.0318 Henry. Or in other words, inductance is 31.8 millihenries, right? So here come the end of this problem. We will proceed with the next one. A voltage E is given by 250 sin omega t when applied to a resistor is found to give a power of 100 watts. That is, in a circuit we are having a resistor and the supply voltage is this one, and the power dissipated in the resistor is 100 watts, right? Find the value of resistor and write the equation for current. State whether the value of resistor varies when the frequency is changed. We need to calculate what is the value of R, and we need to write the expression for current, and when the frequency is changed, we should analyze whether the value of resistor remains the same or it gets changed, right? So here you see E is equal to 250 sin omega t. So that is, again this is an expression for voltage, okay, either E or V. So again what is this? This is the maximum value, right? That is V is equal to, generally we will write like this, right? V is equal to Vm into sin omega t. So here the value of Vm is 250 and the power is given as 100 watts, right? So what is the value of Vrms? Vrms is given by 0.707 times of Emax or Vmax, okay? You can use anything. So where the value of maximum voltage is 250, so just substitute it here and the answer is 176.75 volt, right? And the next thing is power is given, right? So P is given by V into I, therefore I is nothing but P by V. We know the value of P, we know the value of V here, okay? Whenever we are substituting, we should always use the value of RMS, okay? RMS will be used at the maximum. So 100 by this, that gives the answer of 0.566 amps. And the next thing is we need to calculate the resistor value, right? So by Ohm's law, R is given by V by I. So V is nothing but Vrms, it is 176.75, and here the value of I is 0.566. So just substitute it here and the answer is 312 ohms here, right? So we had calculated the value of R. And the next thing is we have to find the expression for current. So the current is generally given by V by R. So here it is E by R. So E, the value of E is given as 250 sin omega t divided by the value of R is 312 here. So when you substitute here, the value of I is calculated as 0.8 sin omega t, right? So the last thing to be calculated is when the frequency is changed, we have to tell whether the value of R remains the same or it gets varied. So here you see the thing, as we all know, the resistor is a thing which is independent of frequency. That is, in the case of AC or DC, whatever may be the thing, the R is simply calculated by how we calculate the R, it is given by V by I. Whereas in the case of inductors and capacitors, we will be using a different formula, right? So inductor is XL and capacitor is XC. In both these parameters, you see XL is represented as L omega and here it is represented as 1 by C omega, right? So what is omega? Omega is nothing but 2 pi f. So whenever the frequency gets changed, automatically the value of XL and XC will get varied. But whereas in the case of resistors, resistor is independent of frequency. You see, it depends upon only voltage and current and not on the frequency. Therefore, the variation of frequency will never affect the value of resistance, right? So problem number 5 gets over here. We will proceed with the problem number 6. A voltage of 100 volt is applied to a capacitor of 12 microfarad. The current is 0.5 amps. What must be the frequency of the supply? So here we need to calculate the frequency. So the circuit has a voltage source, it has a capacitor, right? And the current is 0.5 amps. So this is our circuit diagram, right? Now we need to calculate frequency F. So for that, the voltage is given by, because it is a capacitor circuit, so voltage is given as I into XC. Therefore, XC is given by V by I here. So the value of V is 100 and the value of current is 0.5. It is directly given in the problem. Just substitute the values, right? Now the same XC can be written as 1 by omega C. And omega is nothing but 2 pi f, right? So we need to calculate the value of frequency. So just move this frequency to the right hand side and bring this 200 to the left hand side. So f is given by 1 by 2 pi c into 200. So the value of capacitance is given in the problem. It is again 12 into 10 to the power minus 6. So once you solve this, the value of frequency is calculated as 66.3 hertz, right? So here comes the end of the problem. If you have any doubt, let me know in the comment section. So all these problems are solved by using the basic formulas, right? So that's it. Thank you.